Thanks for joining. Today is day number 9, and today we are going to learn a little bit more about firepower and within firepower how the packet flow or how the traffic flow is happening. Now, this is going to be very important session because we are going to learn that behind the scene how the traffic flow is happening within the firepower. And with respect to that, I will go and perform the lab. We'll go and see that exactly that we have in the blueprint means exactly that we have in theory same way we can go and examine in the lab as well. Okay, so let's go and understand the packet flow. And with respect to packet flow, today we are going to perform lab related to pre-filter policy. Now, what does it mean by pre-filter policy? How it is working? That I'm going to explain as well today. All right. So as we know that the FTD we have, the secure firewall that we have, having two portion. One portion is normal ASA, where it can go and do the maybe L2 up to L3 level of checking. And then the other portion that it has, it having snort IPS engine or snort engine. So with respect to snort engine, it can go and do advanced level of inspection. So that means it can go and do uh, above L3 or L4 level of inspection, application level inspection and all. Now here in the diagram, you can see clearly that our ASA path, and it's very important that you can see the flow. So when a packet is coming, that packet, if you go and put some checks that okay, that packet should go for snort inspection as well, then it will again go to the snort inspection. You can see the path here. It is going to the snort inspection, right? And then it is again coming back. So again it is coming back to the ASA path. So if I can go and draw, you can see the packet is coming, it is going to snort inspection, again it is coming back, and then again it is coming to the ASA engine. Why? Because from that side it has to go and reach to the egress interface. Right? So
Right.
that's very much that is happening within all the use cases we have within all the next generation firewall. Okay. But again, if you go and check that what type of inspection we have, so in this diagram, clearly you can see that we have three different section. Three different section means that initially that when the packet is coming, going inside the, coming from the ingress and going to the egress. So this is something that is a starting. The journey of packet is starting, and here you can see you can mark this as a part 1, then you can mark this as a part 2, and then you can mark this as a part 3. So three different logical locations that it is going through, and all these three different logical locations, you'll find that different sections are there. So what sections they have, different sections they have, as you can see in the diagram. So let me go and quickly highlight this because this is very important and we are going to learn more and more in this section today. So here you can see that packet that is ingressing, it is going with different type of checks. So ingress interface, right? Then existing connection, it will go and check obviously in the connection table. So all the ASA firewall will go and check the connection table that is this packet is new or already we have flow for this particular packet. Now, if it is already there means if the connection will be there, if inside the flow table, inside the connection table, then you can see the first path. Directly it is going, reaching here. Let me clean this. So directly it is going and reaching here towards L3, L4 ACL. Now in the upcoming session, I am going to cover each every section that you can see in the diagram. One by one, we'll go and check each and everything. Okay, so don't worry. We have full-fledged covering related to all these options that you can see in your diagram. So if the connection is already there, then directly it will go and reach to a place where it has two paths, right? Where it has two paths that it can go to the snot. So it can go to the snot means it can go in this direction or it can go in this direction, right? This direction, or it can go to this direction. Now, suppose, sometimes in our policy, what we are doing, we are enabling the inspection rule. We are enabling the file analysis rule. Okay, means clearly we are telling that particular access policy that you have to go and check the obviously you have to go and check with respect to snort engine. So inspection means that that particular packet will go for further analysis. uh, Obviously who will do the analysis? Behind the scenes snort engine is there, who will go and check the IPS IDS settings, check the file settings and all. Great. So if the answer is no, then it will go to the next phase. And what is that? Untranslated NAT or egress interface. Here you can see the animation. So let me quickly go and read through all these points that we have. Packet arrives on the ingress interface. Great. Then what is happening? The input counters are incremented by NIC and periodically retrieved by CPU. That's okay. Then it will go and check that for this particular packet, do we have existing flow or not? If we have existing flow, it will reach to DAQ. This is something data acquisition queue. At the moment, you think that this is a queue or this is some sort of buffer. So here packets are getting buffered, and then either it can go to the QS or it can go to the ASA line. Two lines are there. Go further analysis towards QS with respect to snort, or directly stay there in the ASA path. So here you can see that ASA engine checks for existing connection. If match is found, packet uses fast path bypassing the basic checks. So then packet is reaching for the NAT. Okay. Now here you can see that egress interface determination. In case there is a destination NAT or unnat, the egress interface will determine based on the NAT rule. Unless route lookup is preferred, identity NAT. What it is telling that it will go and check what type of NAT it has. If it has something called destination NAT, then it will again go to the next phase, because here if they go and do the route lookup, that is nothing but the identity NAT, means the self to self type of translation. And if you go and run this command, show capture DMG packet number 3 trace detail, this is at the unnat. If you go and check packet 2 trace, this will be flow lookup. So all the places behind the scene, it is telling that at what stage it is reaching. And then you can see that when it is in the ingress, the third point here is the pre-filter policy. That is our agenda for today's session. So today we are going to learn about pre-filter policy and what's the use of pre-filter policy. Okay. By any chance, if you know what does it mean by pre-filter policy, you can tell me that.
Yeah, I have no idea, man. I've never heard of that.
Okay, no problem. So this pre-filter policy is a policy that will be used for some special cases. That is special cases. What are those special cases? I will show you in the slide. But in general, when we are creating some sort of tunnel like GRE tunnel or any type of channel, there are 3 4 options. I will show you in the configuration as well. But mostly for tunnel traffic. Now tunnel traffic means, and you can see here in the diagram what it is telling, that if it is applying the pre-filter policy. So suppose if you go and create pre-filter policy for certain type of traffic, that means you can see the fast path. So directly it is skipping few of the steps. First of all, it is skipping the snort inspection. It will not go for snort inspection, but that's not 100% true. But you will see that in upcoming slide that there are 3 different options. You want to drop it, you want to allow it, you want to analyze it. So if you are going to analyze the packet, that option that we have in the pre-filter policy, then only it will go to the snort engine. Otherwise the flow will be like this, and here you can see it is skipping some of the steps because it is assuming that this is a tunnel type of traffic. No need to do this level of inspection. Okay, so we'll understand about that. Let's move from the unnat or egress interface to the pre-filter policy. And here you can see in the diagram I have given. In our lab, we know that we have 2 different Linux operating system. One of the device that we have in our lab is having inside uh, Linux operating system sent to us, and one is outside. We know that the interface IPs that we have is inside IP is 10.202, outside is 133.202, and you can see that if you go and create the pre-filter policy, that means we can go and create tunnel in between that. And if we go and create the tunnel, then what will happen? That it will not go and do all these many checks and go inside the ASA data path or ASA path. Rather than the pre-filter policy, you can see at the moment it will reach here to the pre-filter policy, it will skip few of the path and it will go to the destination. So now let's try to understand about pre-filter policy. It got introduced in the version 6.1, that is very much the latest. Serves 2 main purpose. And what type of tunnel? So add additional flexibility when it comes to handling tunnel traffic like GRE, IP in IP, IPv6 in IP, some sort of translation, Terror Report 354 from its tunnel level translation, something like that. Mostly we are going to use GRE. So when you have some sort of tunnel traffic, then free pre-filter policy will come into the picture. It will provide early access control EAC, which allows a flow to bypass completely the snort engine. That's the key. We are bypassing this snort engine, means we are using some fast path method to stay there in the ASA path rather than we are going into the snort verdict. Same thing repeating here. Great. So how we can go and create it? Anyways, I'm going to show you in the lab session that how you can go and create the free filter policy, how you can go and edit the policy and all. Okay. So the lab section I'm going to show you in a while, in maybe 5-10 minutes. Uh, but these are the steps that you can go inside the policies. Once you are in the policies, new policies, there in the new policy you have option to call add a pre-filter rule. You can go and create it. Once you go and create this policy, then again you have to come to the access control policy. Okay, and there you have to map it with the pre-filter policy. I will show you that. Now once you create that pre-filter policy, then again we have to go and allow certain traffic inside the access control policy. For example, we'll go and create GRE based traffic pattern. So once you have the GRE based traffic pattern, obviously whenever you have tunnel traffic, that means you have something called inner IP header, outer IP header. So how the checks will happen? So ASA will go and check the outer IP header. FirePower will go and check the inner IP header. Now here maybe you can ask me that I told you that, oh, pre-filter policy, that means simply skipping this not engine, right? But that is not 100% right, because these pre-filter policies, you can see that while creating the rule, we have option to do the analyze, block, fast path. When you will go and use the fast path, only at that time, fast path, it will go and bypass the snort inspection. If you block anyways, it will block everything, right? And if you go and use this option called analyze, then in that case, it will go towards the snort.
So
Okay?
that means
Yeah.
you want it to analyze.
Yeah. So this is up to us, that if you want to analyze, so in that case, it will go towards the snort engine. If we are using fast path, it will skip directly. It will stay there in ASA path. It will reach to the destination, and block means block. So three mode we have that we can go and apply this rule. Three
Right.
options we have. Great. So here you can see that block means drop the tunnel traffic, fast path means bypass the snort engine, analyze means will send the tunnel traffic to snort engine, and optionally allows traffic tagging as well. How this analyze work? Analyze work means that obviously it will go and put the rule. So here you can see in the animation diagram, a GRE packet, first of all hitting to ASA engine, then because the analyze part is enabled, so then ASA is sending that packet for snort inspection. Snort will go and check the next generation firewall dot rules. It will go and check all those traffic, everything, and then it will revert back that traffic towards the ASA firewall. And from the ASA firewall, it will go exit, means it will go outside. Again, we have discussed this thing earlier, that we have something called early access control policy. That means that you are going to use the fast path. So if you go use the fast path, then it will bypass the snort. Okay. In our lab, what we are going to do, that obviously we'll go and create the pre-filter policy. Now we know that we can go inside the policies, and we can go create access control policy, ACPs, right? Inside access control policy, we'll go and block the GRE traffic for ICMP, just for ICMP, and then we'll go and allow all type of GRE traffic. Okay, so there is no problem. We'll go and create the GRE tunnel between www in, www out. Two web servers are there, or two servers are there. But in that case also, we'll go and block the traffic related to ICMP with this ACP, just to do the verification, and except ICMP, all those traffics are allowed. So how it is, we know that we have dub, www in, and then you have FirePower, and then you have dub out. In between, we'll go and create the tunnel. Even we have the tunnel, right? But it's still, this tunnel traffic has been analyzed by the ASA firewall. If we go and use the analyze keyword, even it can go to snort as well if we have the analyze keyword. So dub in to dub out, the tunnel we have, will go and block the ICMP traffic. The rest everything will be allowed. And one thing here to note is this. Let me clean this stuff. Anyways, in the lab section, it will be clear. But here you can see pre-filter policy. So while you are creating the access control policy, there you will find that option that you have to go and tag this policy with the pre-filter policy. And once you have the pre-filter policy, what is happening, and this is very important. So what is happening, that pre-filter rules are deployed to ASA as L3, L4 ACE entry, access control entries, and placed above the normal ACE. So these policies, they are actually coming first, and then access control list, ACLs, or ACE entries, access control entries, they are coming into the picture. So they have some high priority than this L3, L4 ACL. Okay, and that's why they are being read within the ASA firewall. You can clearly see if you go and do show access list, you can see here FTD pre-filter policies, and then let me show here that you can see that you have the early access control pre-filter rules, then you have tunnel pre-filter rules, and then only you have the L3, L4 access control entities. Yes. All right. Actually, this is little bit, you can say, the advanced topic that we have started today, because now you have complete packet flow in your front. And in upcoming session, I will go and hit all these options you are seeing, because everywhere you'll find something is happening. So if you go and check somewhere, you can see that SSL decryption is happening. And then you can see identity policy, L4 ACL, QoS, network discovery, AMP rules, NOT rules, all these advanced checks that we have. And in the ASA path flow update, ALG checks NAT IP header, QoS, VPN, L3 route, L2 route, L2 address, and then finally reach to the destination. Okay. So this is the theory for today's class only, but anyways, we are going to continue the same journey. It will take maybe 3 to 4 days just to complete the packet flow. And
Yeah.
what I will do with this packet flow, we'll perform the lab task as well. Okay. So being said this, let's go and perform the pre-filter policy lab task. What I have done, as I am doing this nowadays because so many steps are there, so I have noted down all the steps here in the notepad under day number 9 and the same file, and I have shared that file, and you will get this file under yesterday recordings, day 8 recording. This file is there. Okay, and this file is keep populating. So we have to go and create the pre-filter policy. What we'll do, that we'll go and create the tunnel zone, we'll create the pre-filter policy, we'll go and modify the access control policy, and then we'll do the testing, right? So even before starting that, in this lab we'll find that we'll go to the lab section. Okay, in that lab section, we'll log into the inside Linux box and the outside Linux box, and we'll create the tunnel. Okay, we'll create the tunnel. Once we have the tunnel, then we'll log into next generation firewall, and we'll check that GRE tunnel is up or not in between these two servers. Okay, then we'll do the IPS capability checking, because you have the tunnel, but at the moment we haven't created the pre-filter policy. We'll go and check the IPS rule. Okay, so first of all, we'll go and complete these many steps. Then I will go and show you that how we can go and create the pre-filter policies and all. So let me quickly do this thing. Why not? Let's copy this entire notes. Whatever we have is actually this is little bit uh, big lab. I'll check that. Let me quickly go and log into the lab section. 3 SJC, and what's the user 163 and the password 506860. SGSC. Try to connect, and here we are. Okay, so I am logging in here. First time, obviously, it will take few more minutes. It's loading, no problem. Let him load. All right, so while it is loading, why not we can go to um, the servers that we have, right? And even I have the notepad as well. So let's go and first of all copy all the steps in the local notepad. Let me go and click to the start button. I think it is taking time, still loading. No problem, let him load, and then we'll start our steps. Meanwhile, you understood all the flow and everything, right?
It's advanced. But yeah, I'll eventually get it. I got the CCNP security book, so I'm reading that just so I get the theory a lot better.
Okay, and I don't know this flow is there in CCNP security book or not, because this slide that I took here is directly taken from some sort of internal Cisco document.
Yeah, I had the book, and it's about time I just sit down and read it. So
Okay. All right. Okay, so let's click login here. It will take some time to log in. Meanwhile, why not copy that command in the notepad plus plus. So let me go and open notepad plus plus. What happened? Why it is not logging in? Okay, it's working now. It's a little bit delay is there, but no problem. Let me quickly go and open notepad plus plus and put this is the font size and the plus. All right, so what we will do here that first of all we'll go and create that tunnel in between the inside and outside. So if interface up tunnel 0 like that is the command. Let me quickly go and close this first of all, because I want inside and outside server. So let's see where it is. The inside Linux I can see, I think root and 1 2 3 4 5 is the inside. Let's go and create one more that will be outside. So let's see where we have the outside Linux. And let me scroll this. Okay, so you have inside, you have outside, and then I should go and open next generation firewall as well. So next generation firewall 1, because there we can go and check the flow. All right. So let me push here. Now let's go to inside. We can go and do see interface up tunnel 0. And now you can go and check if config like that, interface config. We can see tunnel 0 having IP 10301, and you can see that the next destination is 10302, that's creating the tunnel. Here also we can go and do if interface up tunnel 0, and we can go and check if config, interface config, and we can see that interface is 10.30.2, net mask is this, destination is this. So perfect, we have now tunnel in between inside server and outside server. And since we have some policy like NAT policy and access control policy created in our previous section, so that rule is there that the inside can go and reach to the outside. So now if we go to the firepower and if we go and check some command, maybe show connection, include GRE, you can see clearly that it is telling that yes, from interface 10, that is the inside zone 10 interface. This is the IP. You can see the inner IP and outer IP. So this is the IP. It can go and reach to the outside. Okay, and so that's the thing that we have the tunnel, and we can go and check the show connection detail, and then we can go and include GRE. That's okay. So we have a GRE in between in and out. That's okay. Now what we will do, we'll go and create the pre-filter policy, because for tunnel like GRE tunnel, IP and IP, etc., we can go and create that. Now before doing that, let's go and check at the moment whatever default policies we have, is it hitting the IPS? IPS means the snort engine. So if it is hitting the IPS rules, that means it is hitting the snort engine, right? So let's try to generate the intrusion event. We can go to the inside server. We can do FTP. What it is telling that you can go to the inside server and try to do FTP and try to get the root access to the outside server. So if I go here and type FTP 10.30.3, this is the tunnel IP of the outside interface. And once you're here, then you can log in as a guest, password this, and then use cd root. That means um, you can connection timeout, no problem. Cd, change the directory as root. Means you're trying to get that access as a root access, something like that. Let me try one more time. From inside, you want outside connection. Seems it has some issue, is not connecting, some timeouts we are getting, and maybe some rules that is not hitting from inside to outside inside this IP, inside this access control policy. So let's see. Um, let's go and check. Oh, I don't know if these rules are deployed. Let's see. Mm, okay. This is just the old policies are deployed or not. So that's I'm checking. It seems that it should be deployed old policy, and inside old access control policy, what I'm doing, I'm trying this FTP access, and no problem. Let's see. Let's go back here to the FTD. We have, I'm going to check show running configuration like in Cisco we are doing, and still it is deploying. So let this get deployed. It's 75% deployed. 83% completed, right? So let's do show running configuration. I just wanted to check the access control policy. Even we'll go and check that access control policy in the GUI as well. So there is no problem. Inside that access control policy, from inside to outside when we are going, right? So for that inside to outside, do we have IPS rules enabled or not? That's the thing I just wanted to check here. Better we'll go and check. You can see that some tunnel rule and all those things are there. IP and IP prefilter, etc., etc. Anyways, let's go here to the policies, access control policy. What policy we have? Let's see that. We have this next generation new policy. And inside that, I can see that there is only one default policy that is telling that source is outside coming to inside. Any outside wants to reach to inside with these services, allow them. So basically, we are not telling that go outside. That means that we are not telling within this rule that www in go to www out, right? Let's quickly go and check our slide. I have given one summary here somewhere. Oh, this one. This is actually whatever we are creating. So here you can see rule number 9 that we have, allow outbound connection. This we have created earlier, no doubt about that. Allow outbound, what it is telling that in zone is going to out zone. Okay, so I just wanted to add this because this web server access is okay. We have that. Rule number 11 we have in our FTD. I just wanted to add this in zone 1 go to out zone. That's it. Okay, let's quickly go and add that. So I can go and add one rule, and I'll give the name allow web access outbound from into out, and insert where into the default action is allow. That's very much okay. And do we have any priority? Below rule, above rule. Above rule number 1, yes. Above rule number 1, I want to insert there. Then what's the zone? Zone is the source is inside, wants to go to outside. And then even we can go and specify actually. If we want to specify www in going to www out. Okay, because we are testing only in to out. So this is my source, and then www out is my destination, and then we should go and use this inspection policy. So this is intrusion policy. Again, in upcoming class we are going to discuss more about this, the file policy, intrusion policy. Want to log in, the beginning, click add, and click save. So you can see clearly on top of that, uh, in zone 1 to out zone, ww to w, like that, any, right? So we have one more rule there. You can go and click deployment. This is not that we are doing pre-filter and all. We are going to create the pre-filter policy in a while. We'll do that. But this is just that we are preparing our lab, the prerequisites for the lab. So it's doing the deployment. Meanwhile, it will do the deployment where we are in our steps. So we should go and do the FTP and check the inspection rule from inside to outside. And we should find that our IPS IDS rule is not engine. I will go and work on this case. Then we can go to the analysis intrusion event. We can go and verify this anomaly, this abnormal behavior, and we should observe that the source and destination inside that event analysis. Okay, so let's do up to this point and then we'll go and check the tunnel zone and all. So we are here, you can see it is in progress. That's great. Now I can go to the inside Linux server. Let me go and click on, now it is completed. So try to FTP, because now inside will go and reach any of the service to outside. It has some connection timeout. That is not good. But anyways, let me check. Try to get the root access. Not connected. Okay. And if you go to analysis, let's see that intrusion events. Although this thing we have checked earlier in our previous section, I have shown you that some root related issue is coming. Uh, we should have all the other parameters as well, like we should have the NAT configuration and all. Maybe I'm I don't have that much at the moment, but we have seen this in our previous maybe day number 3 or day number 4. I have shown you that um, if you go and run these commands, it will go and generate some sort of trigger. And this is actually a new lab. I haven't created all the rules. So maybe let's go and check the device and the NAT rule. What are the things we need? We need the NAT rule. We need this access control rules. That's it. So if I go and check the NAT, let's see the NAT rule. Inside NAT, we have allow web access. That's the rule that we should have. And it is telling that in zone 1 can go to out zone, source is in, and destination is out. That's okay. It's very much okay. Let me go to the policy one more time. Let's go back here. So everything is okay. Only thing is that I'm not able to show you that it is hitting the IPS rule or the SNOT rule with the normal data traffic. But we'll go and create the pre-filter policy, and then also I'll come back and we'll verify that. Okay, and if you go and edit, make sure that in the inspection we have intrusion. That's okay. That's great. In both the ACP access control policy, we should have that. Web access from out to in. Yeah, so those IPS rules are enabled. Okay, and you can see that the rule we have. Okay, I'll go and create that. Allow web access allows. That's okay. Now we are very much good here. We can go and create the pre-filter rules. So let's go ahead to the notepad, and these are the basic check that, but once you want to go and create the pre-filter policy, obviously it can go and bypass the snort engine if we go and use fast path, right? In the option, I'll show you that. Before that, you should go and create one tunnel zone inside the object. I'll show you that, and then we can go and create the this pre-filter policy. So let's go step by step. You can go to object management. We need one object called GRE inside the tunnel zone. So once we are here, you can see in the bottom we have one name called tunnel zone. If you go and click there, you'll find that there is one object already. There is just the name. Tag is GRE. That's it. It's very easy to create. You can go and create any. Like you can go and create add tunnel zone. Just give the name and that's it. Okay. So we have one zone called GRE. This we are going to use inside our policy. So you can go to policy. Once you click to the policy, you can see that in the bottom we have option called pre-filter, because now we want to create pre-filter policy, new policy. What will be the name for this policy?
That in zone, out zone,
Yeah, our tunnel
our tunnel.
pre-filter. Any name we can, any logical name we can go and give. There's no problem. So let's click save our pre-filter policy, something like that. Now this pre-filter policy, you can see this thing is coming. Clearly you can see that what's the source object, destination object, source network, just like any other rule, right? Now here you want to add tunnel rule or you want to add pre-filter rule. It is asking what you want to create. Obviously,
Probably the pre-filter rule.
yes, yeah. So we want to create the pre-filter rule. So now you can see the path as well. I have given the notepad just for the reference. So we can go to policy, we can go to access control, pre-filter. We can go and give any logical name. There is no problem. Then we should go and add the tunnel rule. Wow. So we can go and add the tunnel rule. The name is any name we can go and give. Then assign the tunnel zone. I will show you that how it will be. Then give the port, add the rule, click and save the pre-filter policy. So I can see that we have option. We can go and add tunnel rule. We are getting all these options. Really great. And you can see that we have add pre-filter rule. There also we are getting almost all those options, but the difference here is this: the pre-filter rules perform early handling of the traffic based on the simple network, fast path traffic bypass. So the thing here is this, that you can see that action tab. In within action tab, you can see that by default it is analyze. If you go and expand this, you have three options: analyze, block, fast path. And even in the tunnel rule, if you go, you can see the action button, three options.
Yeah.
So as
Mm.
per our configuration, non-encrypted tunnels, we want to create the tunnel rule. Okay, so I'll go and give the name tunnel rule for pre-filter, pre-filters, filter hit, etc. Rule is enable insert below above. That's okay because this is the only rule we have. um, we can go and play around with this. At the moment I'll give analyze. Then assign tunnel zone. Remember we have created one tunnel zone called GRE, and
Mhm.
that's great. If you have any time range for this access list, this is nice feature that Cisco has introduced. Time range ACLs, what time range you want to apply this rule, you can go and create and you can call here, right? Then the interface object, where to where, right? And then the tunnel endpoint. So those things we have to go and define. So that's okay. We are giving the name, we are giving the zone, we should go and give all these options like what's the encapsulation, and then we should go and add the rule. Okay. So that's very much okay. If we leave it any that is also okay. But we know that we have WW in to WW out as a network, and we know that we have in zone 1 to out zone.
Yeah.
Otherwise, I can leave it as default. There's no problem. We'll come back later on this. Then the tunnel endpoints also we can go and define. And I can go to the VLAN tag. We know that we have tag called GRE. Do we have that GRE tag? If tag is not there, we can go and create that tab or apply here or leave this as default. We can go to the encapsulation. Now you can say encapsulation GRE. See, these four features are available inside the pre-filter. GRE, IP in IP, IP in IPv6 in IP enter radio. All right. I think we are very much good. We can go and click add. So now you can see that we have one default type of rule where we are adding GRE. Even we can go and add some more specific source and destination as well, but that's okay. Click save. One more time. So now we have our pre-filter policy built in. Okay, now we have to go and modify our access control policy, because inside access control policy we have to go and call this. Okay, so we'll go inside our access control policy and we are going to modify this. What it is telling that you go and call this policy first. Okay, and then you can go to the access policy. Inside access policy you can go and create different policies, and different policies means that here you can go and create at least two policy that block ICMP over GRE. So within this tunnel you block ICMP traffic, and within this tunnel you allow rest of the traffic. That's it. Okay, so we are very much good in the shape. Oops. We can go here and we can go here. Now, once your pre-filter policy is built, go back to your access control policy. So we know that that is the first policy we have in the list. Now we are inside the access control policy, which is telling that it is outdated. Just click there and be very careful at this point of time while calling the pre-filter policy, because on top you can see this place. Let me highlight that. Okay.
Default pre-filter policy.
Yeah.
Yeah.
This
Yep.
section we need to go and click. So if you click there, that blue icon, oops. So it will tell you that pre-filter policy, you want to use default or you have your own. So we have our own called our tunnel pre-filter that just now we have created. Right, and now you can see on top that it's that has been changed. Now it is our tunnel pre-filter, right?
Right.
So that's the way that we are editing the policy. We can go and save this first. And since this policy is glued with the access control policy, it has higher priority. So first this policy will be served. And in this policy, if we are bypassing the IPS IDS, so that means that it will directly, it will directly do some sort of fast path, and then it will skip few of the steps and it will go next. Now here we want to add few rules for GRE traffic. So let's go and add it. See, GRE block ICMP. traffic, and we want to add this inside the mandatory, because this is block it, and from where to where we want to block. So here you can see that source zone is GRE and the
GRE.
rest, yeah. So we want to block for GRE. We can go here and check the zone, and in this zone you'll find GRE as a source. And rest is any except this application. So what application you want to block? The application we want to block is
ICMP.
ICMP. Yeah. So do we have ICMP here? Let's see. So application ICMP, click add. Because since it is blocking, so we don't want to do any inspection, right? Like IPS, IDS and all. Anyways, what we are doing, ICMP, HTTPS, what is this destination? Oops, where we are. What I have done, destination ports. Why I took destination port like this? Have I clicked some wrong? Let me see. Port. So ports. By default, these are there. Let me quickly delete. I'm just matching whatever we have here in this. So here you can see that GRE and then ICMP and it's block, right? And block, even you can block and log as well. So once you are here, you can click here. You want to block and then you want to log as well. So log at the beginning of connection. That's very much good. So we created one policy on top that within the GRE tunnel, we are blocking the ICMP destination network WW. Even I don't have destination network here, right? Everything is any, right? So that's okay. It's just matching that rule that we have. Even you can refer the notepad as well. So now I can go here and you can see that the network that we have, the destination network is also any. Click save. That's, we are very much good here. And then next rule that we want to create, the next rule that we want to create is that let's see here, that is under default allow GRE traffic, and you can see a zone is GRE and rest everything is any. So very straightforward rule we have, rule number 2. So now I can go and add one rule. This rule will be see, allow GRE traffic. This rule will be inside the default rule. I want to create under default allow, and just the zone is GRE as a source. Rest everything is default here. But still I want to do the inspection. So inspection is this, and file policy is this, and logging here. Click add. So we are very much done. Let's go and save this policy. Now you can see that we have the access control policy with some pre-filters, right? So our tunnel pre-filter policy, once we save this policy, obviously we want to deploy this. So go to the deployment, click deployment, click to the next generation firewall, deploy. It will take maybe 1 to 2 minutes to get deployed. Let this get deployed, and I have given some verification steps as well. So what we have done basically, as we follow this particular document and we have done the deployment, then there are few steps just to do the verification. Okay, once it will get deployed, then we can go to the outside Linux server. We can run this command tcp dump for the tunnel 0 to monitor the tunnel traffic. Okay, and it should give you some sort of output related to the tunnel traffic. Apart from that, we can go to the inside Linux server and we can go use wget. This should succeed. If we do the ping, should block. Okay, so these are the verification steps we want to do, and let's do that. Once it is get post here is 83, now it is completed. Great, so let's go and do the verification. We are here to the inside Linux server. Let's do the ping, because ping should be blocked. See that ping is blocking. And apart from ping, if we go and use say wget, means the other traffic, 10.3.0, other traffic should be allowed. You can see that traffic is allowed, success is okay. That's okay. And if you go here to the outside Linux, if I go and copy this TCP dump, let's go here, copy, and go to outside and open the inside. So now you can see it is listening. And now if you go and do the ping, let's see, it should generate some log like echo request, echo reply, something. That ping is failing. Not seeing any log. That's okay, no problem. Wget, I can see the wget. We are getting this TCP dump. It is telling that what's the tunnel source, what's the tunnel destination, port number 80, which we have done the allow. So it is going through that tunnel, right? And if I go here and do FTP 10.3.0.2, root, what was that? CD something. Change the directory to the root. Wow, we have the root access as well. Great. Login failed. Okay, let's see. Now verification is actually very interesting, then we can go and check that the rules that we have created, they are getting implemented correctly or not. So here we are. We have any root type of means if you go and click here, means it will show you here itself any CD root is there or not chosen and all those things. But anyways, most of the thing related to higher level security, we have lab in the upcoming section. We can go and check that. So point here is this, that what we have done in this scenario is that our pre-filter policy, we should go and check that which particular policy is hitting. And it is there in this slide. Some of the advanced level, output, how it will be. It is there, so I can go, let me show you this. So I can go to where SF security, secure firewall, detection engine, UUID. Let me show you this. So let's go and check the advanced things as well. You can go here to the next generation firewall one. Let's enter. Click enter. I have access. Okay, we have done the lab. There is no problem in the lab. It's working fine. Um, we have all the checks as well. I have done some additional checks as well. But I want to show you some other command as well, little bit advanced. So if you want to check the snot rule, you have to go inside this particular folder. And how we can reach to this? This is something Linux shell, and do we have change directory option? We do not have, seems. So expert, let me check. We are here in the kernel, right? Present working directory. Okay, this is the directory. Let's go to var sf detection engine UUID. Inside detection engine, uh, this is the UUID. Cat next generation firewall rules. Enter. And here the GRE related rule. Maybe the font size is very much very small, but
Okay.
yeah. So you should see that. Let me increase this. Let me increase this, and let me run this one more time. So you should see bypass FQD and should have somewhere GRE is having port number 47, right? Somewhere you will see port number 47, rule related to port number 47. So this is starting from here. This is next. See our access policy. This is the name. Next generation new policy. Something like that. When it has been created. Today only I have created. Then what interfaces we have, what zones we have is very much in detail. HTTP, FQDN, and all those bypass. Then we have this rule, right? We have this rule, allow everything, everything, everything. We have this rule. We have this IPS policy. We have these IPS IDS policies. Unfortunately, I'm not seeing port number 47 here. And while you are creating your object, so if you go to the object, we have only one place here, tunnel zone. And if you go and click here to the add tunnel zone, say if I go and give GRE1, it is not asking me that this GRE1 is port 47 or something. It's just the name we are creating, right?
Yeah.
There's no other problem. And then I have done all those, inspections. I mean, all those rules, call and everything. So whatever policy that we have at the moment, we haven't just specified the port number, but obviously we have option that we can go and specify the port number as well, because the port number option we have. So here if you go and check, it is telling tunnel number 2, any 40. Maybe this is some other name or something, but tunnel 2 here with this some rule allow. Okay, here also allow any. That's okay. Okay, so this is the lab we have related to pre-filter policy. From this session onward, we are going to learn each everything, And whatever inspection like ASA path and IPS path you're seeing, this is true for all the firewall, even SD-WAN firewall as well. So now in SD-WAN, we have ISR routers. Within the ISR routers, we can install some sort of virtual kernel, and then those ISR router can work as a firewall. Not only firewall, they can work as a next generation firewall. So there also the same type of flow is there. Same. So if we understand this flow in one ASA firewall or in one next generation firewall, it will be true for all the firewalls.
Yeah.